Okay, you know that from now on we are recording the session. Okay. Something else as a starting point? No. So now.
Okay, well, thank you for the question, completely. I just want to mention that in my first recording, no, it was in the second recording, when I was calculating not calculating, I was just asking for the total number of albums that John Coltrane produced during his lifetime. If you remember, there is some kind of misalignment between one of the functions, and later I rerun the same code, and the number was different. Okay, I've been trying to investigate what is the source of this, and my only explanation is that actually, given that this is coming from a database, and maybe there was some changes in the database, I don't know. I have the feeling that it's not kind of a problem from the code part, but it's more a problem from the API and from the database, okay? Because I've been trying this code several times, I've been rechecking it, and so on and so forth, and always has been consistent. So this misalignment, actually, I attribute it to maybe there was some change, or maybe there is one album that maybe, some kind of contingency regarding when I ask the data of the API. And let me know that if anyone has some kind of explanation. My feeling is that it comes from some kind of misalignment in that part of the database, okay? But if anyone has any other explanation, please let me know. Okay, so let's start. At this point, Albert, I think I will ask you to turn off the microphone if no one no one is talking, because I retroactively hear myself and other sounds in the classroom.
Excuse me?
Can you mute your microphone, because I'm retroactively asking, I'm hearing myself and some blank noise in the classroom. You know what I mean?
Yeah. Then we should ask for everyone to use his own microphones.
No, I mean, if anyone wants to say anything, just unmute it. But if no one is talking, maybe propose to mute it, if it's fine.
Okay, wait.
Yeah.
You can just mute it from the application. So you can mute it.
Okay.
Okay, thank you. Okay. Well, now I feel more isolated, but I can focus a bit better. Just let me know that if anyone has any comment, any doubt, anything, just stop me at any moment. Okay. Let's make this as collaborative as possible, given that I am quite far from you right now. So even if we're in this online environment, let's try to make it kind of interactive. Okay. Okay. From where I want to start. Okay. Yeah. At this point, if you follow the video, I really hope that you're able to generate this JSON file that is codifying all these relationships in the authorship of albums of a given musician that you choose, or maybe you just decided to use John Coltrane on any other that it was in the Jupyter notebook. Okay, so at this point you should be having. I would like to. Let me do something, just 1 second. Okay, so at this moment, what you should see is you should have one object, okay, which contains this structure. You should have it in the Jupyter notebook. When it is running, there should be a folder which is outputs, and in this output should be this JSON containing this information, okay? And this JSON contains mainly two parts. One is the nodes, which contains the information for each of the nodes, but it's univocal. There is one of these objects for each of the collaborators of, in this case, John Coltrane, okay? And here we have in all of them, okay? So this is nodes, and we have these objects, okay? The first object that appears is John Coltrane, basically because it's the most relevant one, and it's the first one that appears when Python is building this file. And let me stress something that I did not stress enough when I did the video, which is for each of these nodes, we're exporting two things. The first one is ID, which contains the name of the author, in this case, John Coltrane. And then we also have this second key, which is degree, which contains this attribute, which is the degree of the node in the network, which this means that John Coltrane's node has 60 links which are connected to this node, whereas, for instance, André Jolivet has 10 links connected to this node. Okay, this is, I'm pretty sure that you know it, but at this point, you know that this is the degree of the node of the network. Okay, so then again, we have this JSON, which have these nodes, which is a list, okay? And this list contains all these objects, which actually there are 60 nodes. So John Coltrane has a degree of 60 because it's connected to the 60 nodes that we have in this network. So, okay, great, this is consistent. And okay, and for each of the objects, we have the ID and the degree, okay? Second, we have also these links, and in this of these links list, we have this list of links, okay? And for instance, let's explore the first object in which you have a source. So the node, where is the source? And so this, to put it simply, we're connected. In this case, this link is specifying that we are connecting John Coltrane with André Jolivet, okay? And here you can see, for instance, that the weight, and this is something I didn't mention in the video, weight is equal to 1 because I did not codify this information. I just I'm saving it to the data file because if you want, you can explore this possibility. This is not something that we're going to cover, but indeed, this is possible. We can codify the number of co-autorships between John Coltrane and André Jolivet by stating this weight, by including this information in this attribute here, and then this is something that we can visualize. Okay, but as I said, this is something that we are not covering here. It's interesting, of course, but there is a lot to cover, so I thought that it might be enough with what we will be seeing today. But it's really important that at this moment you should be having this JSON file. It should be stored as a JSON file physically in your computer, and you should have it because we are going to use it in a minute. Well, in a minute, in around 45 minutes actually. Okay, so before what I want to do in this lecture is two things. The first one is explain what is observable, what is D3, just some kind of a brief introduction, because I do believe, first of all, that they are wonderful environments and wonderful library. They are really popular, especially D3, but also Observable Notebooks, which is this environment that I hope that by now you had the chance to explore a bit, in which I published this notebook, which is the kind of main reference of this session. Okay, and I hope you had some time to try to understand what is this about. And the second is D3, which in a moment I will be talking more about this library. I just shared in the chat the link to this notebook. Okay, it's really important that you have it because we will be using some of the references and some of the code that I include in this notebook. Okay, so keep it open. You have it in the chat, but also I think that Albert Diaz shared it with you along with the videos. Okay, so let's start. And the idea of this session is, as much as possible, is that you go along with me doing what we will be doing, doing the same things that I'm doing. Of course, maybe sometimes maybe you cannot keep up because this will go with us at some moment because there is a lot to say, but I will love if you can just go at the same pace as I go and explore with me what we are doing. So the first thing that I would like to invite you is that you go to observable.com. That actually, if you have this reference open, actually you're already there. And I would like to invite you to log into the observable environment. You can do that by your own email address. You can do that also using your GitHub account. And I hope that you have a GitHub account at this moment. If you don't have it, maybe you can create it. Okay, I will just give you 30 seconds so you can log in if you are not logging. So please do it if you can by now. Maybe if you don't, you do it by email. You can just have to verify your email address. Okay. While I give you time for doing that, I would like to share with you one specific resource. Okay, which is the one I'm opening right now. Don't worry if you cannot see the screen right now, if you're running and you're trying to log in Observable. Just I would like to point to you these tutorials from Observable, which actually this is new. I've been updating a bit this session. As Albert said, we did this lecture last year, so I've been updating it. There has been some relevant improvements in Observable. Now I think it's clearer, and especially for beginners. If you are maybe you are all familiar with Observable, which, to be honest, that would be wonderful. But for beginners, these tutorials are really good, are really clear. I mean, I've been checking some of the videos, and to be honest, they are really, really clear. So I definitely recommend you these tutorials if you want to drill down a bit more into this world of observable, because it's really simple and it's really powerful. I hope I can try to convey a bit this how it can be useful, because I think for science in general can be a really useful tool for sharing results, for yourself even studying. If I have time at the end to share, show you something that a student from last year did, forking, copying the final result of this session. Okay, I hope I can show you that, because I was pretty happy to see that one student did that. Okay, so at this point, if you have been able to log in, you should see something like, well, if you're in the notebook, you should be something like this. And now let's going to create a new notebook. Okay, so I will create one using my own personal account. And okay, I hope that by now you're with me, that we're at the same place. So something important, let's start. This works pretty more or less equally than a Jupyter notebook. It has some differences, of course, but the idea is more or less the same. So the main principle is that there are cells. Okay, here I have one cell, and this first cell, the first cell of a observable notebook, is always the title. Okay, so since this is just a test, I'm sorry, when I type probably would be a bit annoying. I'm sorry for that. Okay, so this is a test notebook. Okay, so now this observable notebook will have this name, which is test notebook, and I'm going to press shift intro to establish it as the first cell, and also as the title of this notebook. Okay, now let me say to you, there are 4 types of cell. Now the first one is markdown, because it is meant to establish the title, so it's per se, it's observable, it's a markdown cell. Okay, the second one, it can be one of the 4 types. Okay, the first one could be a JavaScript cell, a markdown cell, an HTML cell, or a LaTeX cell. Okay, in a minute I will show you exactly how this works. So the first thing is that, okay, we established the title, and now I'm using a JavaScript cell. I don't know if you're familiar with JavaScript. In case you're not, don't freak out too much. I mean, JavaScript has lots of similarities with Python. It has great differences, because basically JavaScript is a programming language that is intended to run in a browser, and the browser works really differently than it can work in a local environment, but it has also great similarities. So don't stress out too much. I hope you can grasp what we are doing in any case, if you are familiar with Python. Okay, now I'm going to create this cell. Okay, remember that every time that I want to execute the cell, I'm pressing shift intro. Okay, so here we have it. Now I just declared one variable which is called students, which equal to 2. Okay, now I'm going to create another which stays this value, which this variable is students, and it's multiplying it by 2, which, by the way, do not ask me why this is relevant or how this can be useful, but in any case, we have a students equal 2. Okay, now we have a students multiplied by 2. You see, it's pretty simple. Actually, it's really simple. It's really similar to, for instance, an IPython environment or the Jupyter notebook that actually runs on top of the IPython console. Okay, something that I want to show you also important, just this, the basics, is there is this pin. Okay, now as you can see, if I just move, let's say, my mouse out of the cell, the cell it keeps open. Okay, and this is a great difference compared to Jupyter notebooks, in the sense that if I unpin it, you see, the code disappears, and this is key. This is fundamental, because this is really nice, because doing that, you can do something as clean as this notebook, you see, which you don't see the code, you just see the information, and it's prepared it's meant in a way to be more aesthetically appealing, you know, than maybe, for instance, Jupyter, which also can have the statistical component, of course, but in this case it's meant to be like a document. You see the code, and you can edit the code by clicking here. Now you can see my markdown. You see here my markdown, and you can even edit it. I don't know why not works. I don't like this title. I want to name it hello, whatever. The thing is that now I'm editing this network, and I'm editing it locally. Of course, if you change this network in this notebook in your computer, it won't change the version that is published. Okay, I mean now because I'm the I'm the owner of this notebook, I have the possibility to republish it. I'm not going to do it because the change was obviously nothing didn't change. Okay, now let's continue. Another one, something else that I want to show you. We can make multiple operations in a cell. Again, the basis of JavaScript. As we said, we have this variable student too. And something that I was telling you is that there are different kinds of types of cells, and they could be JavaScript, Markdown, HTML, and LaTeX. Okay. This is completely new. I think this has less than 2 months. You can specify the type of the cell by clicking one of these buttons, but classically, and still you can do it like this, and mainly I'm going to do it like this, is you can say Markdown. You see, this is the abbreviation of Markdown, and then if you click Tab, you get these two accents, you know, these acute accents, and within this space now you can type whatever text you want to type in Markdown. Okay, and as probably you're pretty familiar with notebooks, so you're familiar probably with Markdown, and as you know, Markdown, for instance, you can write bold. So my favorite number is, and is will appear as sorry, my favorite. Sorry. Okay. So is going to appear as bold. Okay. Now what I'm doing here in these cells is I want to demonstrate you that it is possible to combine different types of cells. Now you see, for instance, here I'm saying Markdown, and this is Markdown. My number of students is will be appear in bold, and then using this $sign and these brackets, I'm also calling the JavaScript variable of students. You see? So now, since the students variable is equal to 2, now when I shift intro, my favorite number of students is in bold 2. Okay? Now, one of the extraordinary things, or something that personally I really like of Observable, is that it does not work in a linear fashion as it does in Jupyter notebooks, in the sense that you have to execute each of the cells one after the other. You know, if you change the value of the variable at the beginning of your document, then you have to rerun all the cells one after the other if you want that variable change is applied to all the cells. Okay. In Observable, it does not work like this. Actually, the model of an Observable notebook is a network of variables which they are all interwoven. Okay. And this network, this full connection of variables, is dynamic in a way in which if I change the variable of students to 5, now without rerunning the other cells, you can see that my number of students is 5 and 10 or whatever, you see? Because this is not a linear model of executions of cells, but actually is a network of interconnected variables and components, okay? And this is a key component, key idea of Observable. Okay, now, also like in Python, we can have list, okay? And arrays called in JavaScript, and also we can have dictionaries, or as it is called in JavaScript, objects. We can have dictionaries, as it is called in JavaScript, objects. I don't want to say it wrong. Okay. We can also declare functions, and here I'm creating this double product function. Okay. Let me explore it with you. We have this, well, the object just it's like a dictionary. It's just the same. We have this key A, and this value 1. We have the key B and this value 2. Okay, it's just the idea is exactly the same, just the way of declaring it is different from Python, but the idea is exactly the same. Then double product. Okay, we have this function in which it has 2 attributes, x and y, and then we have this double equal to 2. Okay, this is just to demonstrate that you can create variables within a function, and then we have this return parameter, and then what we are doing is multiplying this this attribute and this not attribute, this is a parameter. Well, it's not important. Okay, this parameter by this parameter by 2. Okay, now I'm going to execute this cell, and now let's do the double product of 2 and 3. Okay, and here we have it. 2 per 3 is 6, per 2 is 12. Okay. So the mode of functioning is pretty similar to Python in this sense. Okay. Now, let me show you something else. Okay. Now we declare this function, but these cells you can declare a function per se, but you can also declare a block. Okay, and what is a block? Let me first declare this variable b equal to 15. Now, let me declare one block, which is called area, and a block is declared by using two claudators, you see? And a claudator, a block is not really different than a function. It's just it's a function, it's a kind of function which has no attributes, but which actually uses the variable that are existing in this observable notebook. So within this area, I can use this variable b, you see? So let's create a variable a, which equal to 21. By the way, let is a way to declare variables in JavaScript. There is also var, if anyone is familiar with JavaScript, and also const. But I will be using length because it's scope specific. If anyone wants to know more, I can explain the specific details within let and var, but it's beyond the scope of this class. But I will be using let. It's more safe, let's say. But it depends on what you do, okay? Just I leave it there. Then what I want to do is I will return, okay? So think as a function in which I take this variable a, which by the way, it only exists within this block, within the block area, and I multiply it by b, okay? And this is really important because you see what I'm doing here. I declare this variable b, which exists now, it's available to the whole notebook, and I'm using it within this scope, and I'm using this variable a, which only exists within the block. So to be clear, area is 315, and now if I run a new cell and I'm asked for the value of a, it's undefined because it only exists within this block, but the variable b, it's 15 because it exists and is declared for the whole notebook. Okay, this is important. This is important. Don't worry if you don't grasp everything right now. I hope I'm being clear, but if you don't get everything, don't worry, because indeed, it's a bit different. It's of course similar to Python, but it's also connected to the way that JavaScript works, which, as I said, it's a browser-based programming language, and for that reason, is different from Python. Okay, let's stress a bit more. Okay, I want to be clear about the different types. I think this is important, and actually is a nice functionality as it is for Jupyter notebooks of observable notebooks. I'm going to explore, just provide you a brief example of the types. HTML, okay, for those who are familiar with HTML, I'm creating here this HTML code, which I'm creating this paragraph element, and I'm saying that the style should be yellow and the color of the text should be green, and the text that should be written in this paragraph if I am a highlighted paragraph. Okay, just for you to have this example. Okay, now something that I deem important. Okay, sorry, I thought I deleted something that I need. Is this? As I was saying before, I'm declaring now a markdown. For something, Mary, I haven't said that here. This is an HTML, and I'm declaring this one as HTML, and with a cute accent. I'm including here the paragraph. Okay. Now I'm doing the same, and I'm creating this cell with a markdown and the accent. Okay, just maybe you saw it before. You don't need to write the accent. You just need to write HTML, for instance, and by clicking tab, okay. Actually, this is probably also works. Yeah, okay. By clicking tab, okay, let's say that observable notebooks automatically just places all the information, all the code actually that is needed for this, okay, which is this two accents and now HTML, which is a library of observable. Okay, so as I was saying, markdown, and I just write these two accents, and in between we can write as much markdown as we want. And here what I want to demonstrate is all the different, something that I'm pretty sure that you're familiar with, which is within markdown you have like heading, second heading, third heading, 4, 5. You can also create italic text. You can also by using this BR break. Oh, this comes from beer, not from what was beer. Well, in any case, there's just a break line, okay? Well, I can't remember now. Well, in any case, it's fine. Then with one asterisk, we can create an italic text. With two asterisks, we can create a bold text. By using the sign, sorry, I don't know in English, we can cite text. And also by using again the accent, we can create some like more monograph or like console style font used for used for citing code. Okay, now The last type that we haven't analyzed, which actually for people from, I guess that most of you have some kind of physics, math, computer science background, so probably you're pretty familiar with LaTeX, and you can also integrate LaTeX in observable notebooks, and this is really useful. I mean, I have found lots of examples of observable notebooks with really fancy examples combining formulas and explaining different. It's being used increasingly for divulgation and for for educative resources related to pure science, mathematics, STEAM in general, no, science, technology, engineering, and math. Okay, so for these reasons, I think it's important telling you that you can write the famous Einstein formula or whatever any other that you want, and you can see here you have it rendered as LaTeX. Okay, and now continuing with the idea that I said you before, that you can combine different types of cells. I'm just showing you here that you can combine real-time executed JavaScript with a markdown. Okay, the current time is, again, the $sign, and within brackets, I'm including this, well, this is the date function of JavaScript. Okay, I'm asking to locale. It means locale is my current configuration of my computer in terms of where I am. So to locale time string, it's this one. Okay. Now, as I said, if there is any question, anyone that you want to ask, to any comment also is very welcome. Okay, I will try to go a bit faster. I would like to show something that I think it's pretty cool and it's really useful for observable notebooks, which is called the inputs, the inputs library. Okay, the inputs library, we can use them to create buttons, but also to create radio. Okay, so we can select green, red, blue, or click the button. Okay, or for instance, to insert an input. Okay, so how it works, let me just really briefly explain you how it is declared. We have this inputs library, and then what we are saying is that create me a button of these inputs, and it should have this name, click me. Or for the same for the input for the radio, no, radio buttons, inputs dot radio, and then we have this red, green, blue. We can even add another one, purple. Okay, and the label should be color. Okay, you see we created this object, and this object contains this key label, and this label has this value color, which is specifying here the name of this label. Okay, now I added another radio button, and you have it. Okay, another example, arrange a slider. You see, I can select all these different values from this slider. So, and to do this, we say inputs point.range, which goes from 0 to 255. The step is 1, it can be 2, it can be 3. I'm going to change it to 2 just for you to see it. You see? Now it's every change. You see? It's from the step is 2. And the label again, this object, is favorite number. Okay? Now, how this works actually? Okay, this is pretty fun, no? But really beautiful. Okay, very nice. But okay, how do I get the number of this input? And this is something that I really like because it's really simple. We just need to run the cell. But what happens? That actually, if you run the cell, you're getting the HTML element. Okay, you got a representation in observable of this HTML element. So in order to have a cell which both is showing us this interactive element, HTML element is interactive because we can interact with it, and at the same time it returns us the value that the user is selecting, we need to do something which is called a BWOF. Okay, I'm going to modify this same. So we just have to specify here at the beginning. I don't know if someone saying something. I'm sorry, I cannot understand.
T'hauries de moure a baix en el navegador, perquè aquí es deixa de veure.
Ah, ostres! Ok, i ara ho veieu? No.
Sí, ara sí.
Ostres, disculpeu, vale. Ho tindré en compte, d'acord, gràcies. Okay, sorry for the inconvenience. What I was saying, yeah, that we're using this view of component, which allows us to render the interactive component, and at the same time, it allows us to get the number. So if we just include this view of at the beginning, now as you can see, the slider is exactly the same. Now I am even going to hide the code, and now it does not return the HTML representation of this element in observable, but actually is giving us the number that the user is selecting. And again and again and again, it's dynamic, okay? And this is the powerful aspect of observable. Now, just to show you the whole potentiality, let's say that my favorite number of students is, and now I can just select it. You see? Now I'm combining the value that is coming from this view of this HTML interactive element, and I'm combining it with observable, placing it within it. Okay? Okay. I hope it was clear. And again, if you have any questions, just let me know. Now, the next aspect that I want to comment, because we will need it, is that in JavaScript, and especially in Node.js, if you're familiar with Node, it works the same as in Python. Okay, we need to import the packages that we are going to use. Okay, one of the packages that I will be using is that I will be using is Lodage. Okay, is a library which is used to process data, to make transformations of data, and in order to import any library, there is this function which is called require. So the import in Python is called require in JavaScript, and we just to specify it works as a function. So we have to between parentheses, we have to specify the name of the library within inverted commas. Okay, here we have it. Now we declare it, and we have it available for the whole of the observable notebook. Okay. Now, in the same way, I'm going to ask for D3. You see, I'm asking for require D3, and here I have this arroba 5.8, which actually means that I'm asking for the 5 version 0.8 of D3. Okay, it's specified like this, is the standard specification. Okay, at this point, at this point I should stop for the break, but give me just please just 5 minutes, okay? And because I would like to spend just 2 more things, and I'm going to, this is everything that I wanted to tell you about observable. And let me say again, stress again, that if you want to know more, I really recommend you to check the tutorials, and there are lots of references. I mean, also in the building interactive networks, in the reference notebook, I also send you, I also included, let me show you actually. Okay, in the lower part, here in the end, where is it? Here. Okay, there is a lot of information that I included that I think is could be useful for you. The first one, as I said, observable tutorials. I think they're pretty useful, but also, and this is how I learned because it was the first manual that they created. There is the observable user manual, which is, let's be honest, really useful and really well written. It's if you don't like the tutorials, then this is really fast. Okay. Now, let's continue. Just around 5 more minutes. Let me just explain you really briefly a brief introduction to D3. D3 is a JavaScript library, okay, which allows us to deal with all phases when creating data visualizations, which means D3 is a library which allows us to fetch data, to process the data and prepare it to be plotted. It allows us to deal with mathematical objects, transformations, and simulations. It allows us to manage visual objects and plots. It allows us to manage also the aesthetic component of these visualizations. And additionally, it allows us to add interactivity with the user, which means controlling the mouse click, the hovering, the movements of the mouse, the keyboard interaction, HTML and JavaScript objects interaction, and so on and so forth. So actually, I think it covers pretty everything. So that's why we will only be using D3 along with Lodage. It has to be said though that Lodage is really not needed because you can use what Lodage in general does, or you can just use pure JavaScript. But I will be using Lodage because it became an incredibly used and even on a standard in JavaScript to use it, because it really simplifies your existence, let's say. And I think it's a good practice also that I mentioned Lodage because it's really used nowadays. Okay, what I would really like to stress is that D3 is meant to do lots of things, and D3 it's difficult to stress and to convey how important D3 has become. D3 has become enormously important. It has become like the basis of data visualization. It was created by Mike Bostock, which is kind of the biggest guru, one of the biggest guru in data visualization, definitely. He's a monster. He worked in New York Times data visualization lab some years ago, is I think where he just became famous. And he then realized somehow that there was some data visualization libraries, a big one that was needed really, that was missing in the community. So he created D3, and D3 became a huge monster, like the one of the main pillars in data visualization. Okay, and okay, just in order a bit for you to explore and understand what D3 can do with data, I would like you to spend some time, if you like, and you're motivated, of course, with this D3 gallery. The D3 gallery should be also be here. It is here. You see, I included in this point. So if you have time, I think one of the most beautiful ways to understand really what is D3, but also to understand what are its capabilities, is to spend some time just scrolling down, drilling down this massive gallery, because there are so many examples of different plots. And also it's even interesting for yourself. For me, it has been a way of opening my mind on how to visualize data, you know. Here we have force directed graph, by the way. This is the basis of what we'll be using today. And it's a way to you know, there is so many ways, and it's really beautiful, the ways in which data can be visualized, not only for pragmatical uses, but also for aesthetical reasons. And I think D3 is a really key component, okay? And okay, D3 is huge. As you can understand, doing all of this interactive in a browser, adding all the aesthetical components, all the mathematical transformation of each of these different data visualizations is a lot of things. So we will be just covering just a few things of D3, just a minimum part. And that's why I included here, and I think this is important, Learn D3, an introduction. This is a huge introduction to D3. Actually, it's authored by Mike Bostock, so I definitely recommend it. And then there are other examples that I like D3 tutorial for beginners. Here I included, if you're starting and you really want to explore and to know more and to start using D3 to create data visualization, especially interactive, I definitely recommend you these examples, which are the simplest one. So if you are doing these examples and you want to start doing things, I think that starting for a bar chart and really understanding basic mechanisms of how it functions is really important. Okay. Let me say, just to continue trying to convey how important is D3. By the way, Observable it has been also created by Mike Bostock along with Jeremy and some other people. Just to have some kind of try to explain to you how important Mike Bostock has become for the data visualization community. So on top of D3, there are these Vega Lite, okay, which are two libraries for data visualization that they are becoming enormously popular because they really simplify the process of creating charts, especially Vega Lite. And this probably is a bit old, this Vega Lite, but right now there is a huge integration between Vega Lite and Observable. Okay, and this is beyond this class, not avoid because I'm a huge of Observable. Both combined, I think they are enormously powerful tools. So here you have all this information. It's quite a lot, I know, but if you are eager to know more, you can find it there. Finally, last point. Now I swear. Before going to a break, I would like to scales. Okay, and there are two pillars of the D3 that we will be exploring today. One is scales, and the other one is oh my lord. And the other one is the D3 for simulator, and maybe some other. And the thing is that a scale is a function. Okay, let me copy it for you here so you can see it. Is a function of D3 which allows us to make a transformation between some input type and some domain and to some range. Okay, so let me rephrase it. A scale is nothing else than a transformation function between some input which have some range, so some minimum number and some maximum number, to another range, which is the range. So domain range, you know, is just a function, a linear transformation between one range to another range. Okay, and so what I'm saying here is that I want a linear transformation from this domain. So I will be entering values between this value and this value, and I want it to be linearly transformed from this range to this value. Okay, so this is the domain and this is the range of this function. Okay, sorry that I haven't been completely clear. I hope that by now it's starting to be more clear. So here this is a graphical representation. We have the this is a linear transformation from this minimum value to this maximum value to this range. Okay, domain range, and the input, if it's in the middle, then it just gives us the medium, the mid value. Okay, so now I declare this scale linear, which is stored in this variable, which is x. And then if I ask to this function x of 2.76, which actually is the minimum domain, the value is going to be 0 because it's the minimum range. And if I do the same for the maximum domain, then it will give me the maximum range, which is 800. And then again, as you can see in the chart, if I ask for the medium value, it will give me the medium value of the range. This is important because it allows us to make transformations from some values in our data to some value, to some range in our data chart. Okay, or for instance, we can transform some numerical variable 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to a set of colors. So it allows us to make a transformation from a continuous numerical variable to a continuous color scale. So it's a mapping function in which we specify some input and we get some output. Okay. Here I'm sending to this, I create a scale linear domain. I'm saying that the domain is from 1 to 10, and the range is from white to blue. And do you see what happens when I'm plotting this scale? That it goes, all these points are representing this linear transformation from one value that goes from 1 to the maximum domain. And here I stop, okay? Now let's reconvene in, if it's possible, 10 minutes, if that is fine. Albert, give me your approval, or if not, in whatever you say. And then with all this information, we are going to create the network.
You are asking for a 10-minute break? Can you finish?
Well, yeah, 11, let's do 11. So let's reconvene at 16, at 4:05, okay?
Okay. We can finish.
Thanks. Meanwhile, if anyone has any doubt, I will be around. Okay, so, well, thanks.
Okay. How familiar are you with these observable notebooks? Not at all? Some things are quite similar to the Python notebooks, and so these of the LaTeX and the headings and so. But you see that this type of the interactive, this is what makes it completely different. Because as you will show, you can make very easily. You can have a network, and then you can not only that you can interact with the network, but also that you can let's say play a little bit with the parameters that you want in the way that you want to see just in a single code. In the notebook, you can play it a little bit, but then you have to interact. You have to specify every time. So you have to change the orders of the command line. And so in this way, you can be interactive in the display. So that's the reason for which this library D3. I guess that you would know that. So because you have a subject which is a visualization, data visualization. So what do you exactly mean by data visualization?
It's not D3.
D3.
I mean,
what do you use? Do you work with the Tableau or Tableau C work? It's a library called Live. So basically Tableau. Okay, this is a big library, so then just the other Tableau are just ways to interact and to construct making the visualizations. ¿Estás ready, Arnau?
Stick ready.
Vale, pues como Luis.
Vale. Okay, great. That's good. Okay, I hope that you continue, Albert. Excepto, bueno, más o menos, sí, algo. Okay, I hope that you all could. Albert, t'hauré de demanar si pots parar el micro, disculpa. És que hi ha un petit soroll, saps? I no sé si parleu o... Disculpa. Gràcies. Sorry for that. Okay, I hope that you could all, I don't know, walk a bit or stretch a bit your legs. Okay, now the moment that I don't know you have been waiting for, but let's create a network, okay? For that reason, we're going to create a new notebook, and this notebook will contain, in my case, the John Contrain co-authorship network. Okay, so the first thing that I want to do is to specify that this is the name of this network. Okay, so the first thing, as I said before, we should create a title. Now I created this new notebook, and I added this title. The first thing, and well, I don't know how you do it in Python, but the first thing that I always do when I start doing anything in Python is I just first import the libraries that I'm going to use. So in this case, let's first of all ask for D3. Okay, so as we just seen, I'm declaring this variable D3, and I'm using require to require D3, and I'm using the fifth version. Okay, I would like to, for transparency, I would like to mention that I am using the fifth version, but nowadays the last version is the sixth one, but there has been some change in the drag and drop functionality of the nodes, and I prefer sticking to the fifth one. I mean, it's perfectly fine. It's still actually in kind of development, and it will be for the time being. So I decided just to leave it at the fifth version. But in case you're interested to be, let's say, compliant with the last version of D3, you can check. You can just change it and evaluate exactly what can be not working. Okay. The next thing that I want to import is the Lodage. Okay, so again, I use require, and as I said, Lodage is a library for making data manipulation, and we will be using not a lot here. Just, and as I said, I just wanted to include it because I think it's important for you to know its existence in the JavaScript world. Okay. Before I was saying that at this point you should be having this JSON file, which codifies the information of the musician that you are most interested in. And this JSON file is a file that we generated using the Python the Python notebook that we use in the first two videos. Okay. Now this file should be in your computer locally. And what I invite you now is, if you are following me in real time, is that you go to File Attachments. You see here, there is this button, I hope. Yeah, you can see it exactly. You can see here there is this File Attachments. And in this File Attachment, actually, you can choose to upload the document. Okay? And this is exactly what we are going to do. We are going to, I'm searching locally my file, okay? And what I'm doing now is you cannot see it because I'm just sharing my window, but what I'm doing here probably now, yeah, you can see that now I'm just drag and drop this file, and it's just uploading. It's a file which is only 30 kilobytes, so actually it's a really small file. So importing it's almost immediate. Okay. So the next thing that I'm going to do is I'm going to load this file. Okay, and this is really simple to do it. As you can see here, we have the file uploaded. You can upload until 15 megabytes for each notebook in any sort of files. For instance, if you check the notebook that I shared with you with the reference material, you will see that there I uploaded all of the pictures that I'm using in the notebook. Okay, let me show you because it's pretty interesting. Here you see I just uploaded them, and then if you go here, okay, file actions. In each file action, you can copy usage code. And this usage code is adapted depending on the type of file that I uploaded. If you use an image, this code will be adapted for this sort of type, this sort of as being an image. But in this case, since we have a JSON file, it will be using another sort of library, so the code is different if we are, as this case, using a JSON file. Okay, so I'm going to use this copy usage code, and this is really useful for you. This is super comfortable because now you see file attachment. We have this function from Observable. It is just asking for this file by using its name in inverted quotes, and then it is just saying that, okay, when you have it, just transform it or process it, parse it as JSON. Okay, and let me do a small demonstration of this data. You see? Now, I hope that you can recall from the first part of this class that actually I was showing to you that we have this JSON, which have one key, and this key is an array, that this array is made all these objects, and each of these objects, it has the ID and the degree, and this part is declaring all the nodes that constitute this network. And in the second part there, it contains the links, and each link is an object, and this object has a source, a target, which this name here is the same name as the ID that is being declared in the first part. Okay, this ID, the source and target is this same ID. Okay. Okay. Now, instead of doing it like this, I'm going to do it in a different way because I will share with you the final result, and then it is declared in a different way because we need it. Okay. We need it because, okay, let me first show you how I do it, and then I will explain you why I'm doing it like this. So I will write graph data, and then I will be using this function, await. Okay, and this function, what it's doing is just, it stops the code, it starts running like this, and it stops here until the browser has loaded this file. Okay, and when this is done, then it continues the execution. And by the way, just let me say that if you're not familiar with JavaScript, JavaScript is not an indented language as it is Python. So each of the lines has to end with a okay. So as I can see here, I'm adding it at the end. Okay, this is really important. And now it makes no sense because it's the same as it was before. But I hope we have time. We will see later why I'm doing it like this. Okay, but this just does the same as the line I just wrote. The only thing is that I'm using this await function, which awaits until this file attachment is loaded, and then it just returns it. So we have it available as this graph object for the whole notebook. Okay. Now I'm not using it, as I say, this is kind of useless, but later we will make some transformation of this graph data object before sending it as the graph object. Okay, and that's why I'm doing this, because not now, but later I will use it. Okay, next step. Let's going to declare three functions. The first one, I'm sorry, I'm going to close this. The first one, you will find it here, is the drag function. Okay, this function actually is establishing what happens when we are drag and dropping nodes. Okay, just copy it here. This is a standard function. It is a standard function, though it has to be that I modify it. Okay, I modify it because I want a different kind of behavior that I can show you later. Okay, the next function is the color function. This function is used for codifying the color according to the degree. And as you can see here, what I'm doing is that I'm creating this scale linear, and I'm establishing a domain and then a range. Okay, just I'm stressing. Okay, these scales are really important. We have this 1 to the max degree of the max degree of the max degree, which actually is 60, and the range of this function is between 0.5 and 1. And then I'm using this interpolate blues, which is a function to interpolate one range to a set of colors. Okay, don't worry if you don't completely understand. Just if you have an intuitive idea of what is going on, is more than enough. And then the third question, the third thing that I want to share with you, that I'm sorry I haven't included here, and I'm going to include it right now, is this function. Okay, is the globane. I'm going to now give me 1 second. Okay, this function is really long. It is a function which is made to detect nodes. Okay, and I'm going to publish this notebook, so now you have it, okay? Now you have this JLubain function, and it is used to detect communities in the browser, okay? So let's copy this function. It is really long because actually this was a library before, but at this moment it's not made compliant with the new versions of JavaScript, so sadly we cannot import it. And as far as I know, it has not been made compliant with the new versions of JavaScript, which it does not mean that it works perfectly. The only thing is that we cannot import it because the new mechanisms to import packages or libraries in the new version of JavaScript has changed compared to previous ones. So actually we cannot import it using the require function. We have to kill a function. But don't worry too much about this, just it's an incredibly long function, which is not really beautiful, but it works perfectly fine, okay? This is just a JavaScript version of the Lubain algorithm that is used quite commonly in network science to detect communities in networks, okay? Now we have it here. I really hope that we have time to explore this because this is a nice functionality or a nice exercise, let's say, to detect communities and plot them in real time in the browser. That's all. Now we have the two libraries that we're going to use. We have the data as a graph, and we have this drag function, the color function, and the JLubain. Next step, we will define two constants. The first one is the max node size of the notebook of the network. So I'm establishing this is a constant, and actually this could be any value, but I mean based on the way that notebook and this works, I'm establishing that the maximum size of the node in the network I want it to be 20, okay? And the next one is collide strength, which in a moment you will see where and how I use it, okay? It's used for the function collide and the force collide. Now, let me just bear with me. In a moment, I will explain you how we use this, okay? So we declare these two functions that we are going to use to declare the network, okay? And now, after all this so much long talking and waiting, now let's finally going to create the network. The first thing that we have to do is to create a block. This block will be containing the network, okay? And I'm creating two constants. The first constant is radius range, which equals to 5 until this variable, okay? So what I'm doing here is establishing the range of the node sites in the visualization, okay? I hope that this will become clear afterwards in a while. And the second thing I'm establishing here is the height of the height of the data visualization, which is 600 pixels, okay? Then someone might ask, okay, you're not declaring the width. Why you're not declaring the width? I'm not declaring the width actually because this is something that Observable is providing for me, because this is a responsive browser, and actually this is a responsive application in a browser. So actually it is Observable which continuously telling me which is the width, dynamic width that I can use for my visualization. Okay, so if I type width, the browser is specifying me according to my screen which is the most appropriate dynamic width that I can use so I can perfectly see the results, okay? So width is not something that I will declare, but it's something that I will use from the one that Observable is providing, okay? Now, before continuing, to one important thing, okay, why we are, maybe I should have said this before, but I would like to stress one thing, and I have it clear before doing all of this, going to this, is that why are we doing this? Why are we visualizing a network? Well, a network is a really powerful form of visualization. It allows codifying a lot of complex information, and this is something that I stressed in the first video. And managing all this complex information can be stressful. It can really annoy the user. It can get really confused, you know, how I deal with this information. So what we are trying to do by doing an interactive visualization of a network is that what we're trying to do is to facilitate we facilitate the provision of this information to the user, okay? So we try to make that the user can explore, but also that the information in the network is provided in the most clear way, okay? And in this sense, interactivity, but also dynamic configuration of the physical, the topological or the physical properties of the network actually are really useful to make provide that the way that the network is visualized is more clear for the user, okay? So let me stress this point. So what we will do now is that we will create this network, and this network is interactive. It's alive. It moves automatically. It's like a living object, and this allows us to place some forces, to simulate some forces in the different components of this network. So actually, we understand this network as a living object which is made of different forces, and these different forces allows us to maybe separate more the nodes, or maybe to put them more together, or maybe to create some force that actually allows avoiding overlapping between nodes. And all of these forces together creates a whole simulation of forces which we can tune in order to make the most optimal visualization of the network, so it is as clear as possible for the user. Okay, so keep this in mind, because it's really important, because the underlying basis is creating a force simulation that we tune in a way that makes the visualization of the network as clear as possible, because actually this is the final aim of doing a data visualization of a network. Make it more clear than in other statistical forms. I mean, Matplotlib is pretty good at this, but sometimes there's overlapping of labels, or some nodes are one after the other, especially when the node especially when the network gets bigger and bigger. Okay. So what I'm going to do is I'm going to use D3, specifically one. I will be using one specific function of D3, which is called force simulation, which actually what it does is create simulation of forces. I'm going to try to share with you the code that I'm copying to my notebook, so you can also have it. Okay. And the thing here is the force simulation. Actually, what it's doing, it allows create forces in this network. Okay. Then the force simulation is just the basis. It just create this simulation of forces. And what it's asking is for simulation, it asks us for a specification of the nodes of the network. Okay. And this is what I'm doing here. I'm sending this graph.nodes, and I'm sending this list of objects with all the nodes of the network. Do you remember the object that we have been exploring? I'm just sending here all these nodes. I don't know why my browser is frozen. Okay, you see what I'm sending here is this node. The specification is nodes as objects in a list, because this is the information that actually the force simulation needs. Okay, first thing that I'm doing, as I said, this is a force simulation of multiple forces. So I'm going to add one after the other forces to make this system alive. So the first force that I'm adding is what is called a force link. So, and what is a force link? A force link, what it's doing is it applies a force between the target and the source that are connected by a link. Okay, so to make it more physical, what we're doing here with that is we're simulating a spring, one spring between each of the nodes of this network. So actually what we're doing is creating a whole simulation of a spring mechanical model. So this will work. You have to imagine this as if you were doing in a real world, that you are taking some spheres and you're connecting this sphere with some springs, and then with the springs you just let this system with some energy and then automatically cool down, so that actually it reaches some kind of a stable state in which the distribution of these objects is as clear as possible, and those nodes which are more connected tends to be more connected between them, and those nodes which are more far or they're more disconnected or more far between them are more far physically in the network. So simulating these springs, what it's doing actually is like physically moving those nodes that are more connected together and those which are more far away being more isolated or more disconnected, let's say. Okay, and this is the force link force. To add a force in D3, what I'm doing is I'm adding this force function. I'm calling it link, but it can be any name. I could be using here another name like link force or whatever you like. And then you see there's a comma, and then I'm adding this force link, which is a function of D3. Okay, so I'm adding this D3 force link, and I'm sending here all the graph.links. So I'm sending all these links here, you see. So this list of objects, and I'm saying to these graph.links that the ID. So how to make this clear? So what I'm telling here is that how do I connect, how D3 has to make a relation, the nodes and the links. To do that, I'm saying, okay, you will find the identifier of the nodes. So the source, this value, the identifier of this, you will find it in here. You see, I'm saying data.id, and this is what it's doing, is running through all the nodes, and it's saying you will find the value of the source and target is the identifier of the node, and you will find it in the data of the nodes in the ID key. Okay, so here is iterating from all the nodes and is taking the ID of each of these nodes, and this value, what I'm saying is that this value, the ID, is actually the same value that the source and target we have here. So it is able to make an automatic mapping, understanding that each of the nodes are identified in the source of target by this property that is here in the ID. Okay, I hope that is clear. This is a bit tricky, but if you understood that, is pretty important. Next, another force. Now I'm going to add a force many body. Okay, so what I'm doing here right now is simulating a many body or an n body force that applies. Yeah.
Now, this is so now you are making, so in this way to visualize, you are making restrictions on the display of the nodes on the canvas, and then according to some force, and then you have something similar for the links.
Exactly. So what I'm doing here is, well, the first thing is that here I'm just declaring here I'm saying just, okay, I'm going to create the simulation of forces. You know, is the blueprint. Here we are doing nothing. We're just creating this blueprint in which then we can add different forces. And I'm saying, I'm adding this force. Okay, this first force, what it's doing is simulating a spring. It's making a simulation of a spring mechanical model in which each of the links behaves as links. Okay, so for each of the edges of this notebook, of the network, we are saying to this simulation that they should behave as a spring. Okay, now I'm doing another thing. Now I'm adding another force, which is a force charge, which is being applied to the nodes, not to the links. And what this is doing is simulate a force many body, so an n-body simulation. And what this is doing is creating a gravity force. Okay. So, to be clear, what this is doing is that if the value is negative, and here you can see that it's minus 200, okay, so if it is negative, what it's doing, this is creating a repulsion. Okay, so the spring is trying to get them together, and the force many body, when it's negative, is just is creating a repulsive, you know. So in physical terms, when we have a negative value, as this is the case, this is creating an electrostatic charge simulation. So it is like two negative nodes, two negative particles that they're being like repelled to one to the other. They're being repulsed one to the other. But if I change this value, force many body, and I change this value to a positive one, what will be happening is the contrary. So it is simulating a gravity model in which the nodes are attracted. Okay. So in the first case, I'm adding a force to each of the edges to behave as a link, as a spring. And in the second one, I'm adding a force to each of the nodes to behave either as a repulsive model, if I'm using negative value for the strength, as you can see here, or either as a positive, as a gravity model, so both nodes are attracted if this value is positive. But what I want here is to compensate, because if we just use the spring model, what happens is that the whole network becomes too, you know, boom, it just disappears from the screen. It's too expanded. Okay, so I want some, it's not expanded, because since they are springs, it gets too compressed. Okay, so I want some strength that actually gives some air. It separates a bit. It creates some sort of some kind of electromagnetic simulation model in which the nodes behave as electrons, and all of them, they are a bit repulsed between them. So it also gives a space, and it avoids a bit the overlapping between nodes. Okay. Don't worry, this is a bit complex, I know, but just bear with me and try to get some kind of intuition in which what we are doing here is creating a simulation of forces that we are adding to links and nodes because we want to achieve a specific behavior of this network. Okay. Now I add another force. This force, what it's doing is being applied to both links and to both links and nodes, and this is like a physical force. It's like taking one hand and moving the network to the center of the canvas, okay, to the center of the visualization. Canvas is this place where we are creating all these objects. Okay, so as you can see, it's a force. It is called I call it center, and it's called D3 force center. And what I'm specifying here in the parameters is actually that I want this force to move the whole network to the center of the screen, which actually pretty simple, no? It's width divided by 2 is the x middle, and the I middle is height divided by 2. So what this is doing is this, the whole network is being attracted to the center of the canvas, okay? And finally, the final force, which is indeed useful, is adding this collide force. The collide force, what is doing, and you can see again, I call it collide, but then remember that when I'm creating a force, you can specify the name that you want, and then I'm adding this D3 force collide, and this is what it's doing, is making a simulation that each of the nodes are understood not as a punctual node, not as a point, but they have some kind of radius, so they understood as two-dimensional objects. And by doing this, it allows to verify that we will be avoiding overlapping of nodes. This is a force which is understood to create some sort of radius around the repulsive radius around the notebook, around the, oh my lord, around the nodes, that avoids that other nodes, when they get closer, they overlap. Okay, so force collide, I'm using it here to avoid overlapping of nodes. That's all. Again, to stress it, we created these four forces. The first one is to create a spring simulation, so it gets together and is a mechanical alive system. The second one is to create a bit of repulsive relation between all the nodes, and it gets a bit of air, we can see it better. The third one is moving the whole node, the whole network, to the center of our canvas. And the fourth one is creating some sort of repulsive radius around the node, so we avoid overlapping of the different nodes of the network. Okay, and all these four nodes, all these four forces are all declared simultaneously in this simulation here. So this simulation carries all these forces, and we will just use it to make our network alive. Okay. I would like to say that actually this for simulation, this model of simulation is a bit more advanced than maybe sometimes the one that are used. But I use this one because this one actually I configured by myself because I really like it, and it works really well. Okay, so actually the idea here is simply to share with you this simulation, which I tune it with the ears, and it's a pretty strong simulation that allows us to visualize pretty well the network. Okay, just let me stress one final point, that as you can see here, I created this collide strength, and this is the parameters that we're specifying. You can make a dynamic model by specifying different radius of repulsion between the different nodes, so the overlapping effect for each of the nodes can be different. But in this case, I'm just establishing one constant, and this constant, as you can see here, is the one that we declared at the beginning. So what I'm doing here is that I'm saying I want all the nodes in this network to be equally, has this repulsive anti-overlapping effect of the same magnitude, in this case 20. Okay, the specific characteristics of this is are part in the documentation of D3. Okay, by the way, let me share with you the documentation of this simulation mechanism, which is called 3D Force. And sorry, because I forgot to share with you the force link. And if anyone wants, I'm going to share the other forces, force charts, if anyone is following me in real time. Okay, and I also share with you the documentation of the D3 force, which is this library that actually is documenting this is not a library specifically, it's a function which contains all these mechanisms of simulation of forces. Okay, and by the way, they are not used only for networks, but they are used for several things. Next. Okay, I'm going to declare an SVG component, and before going on, probably I don't know if you're familiar with SVG. If you had did anything in your life regarding design, or you use Illustrator, SVG is a format that actually is called scalable vector graphics, and actually it is used to create vector-based graphics in 2 dimensions. And by the way, I checked it yesterday. Actually, there seems that in a future there will be possible to create 3 dimensions in SVG, but at this moment this is not available. Okay, and SVG is a format that we can use to create vector-based graphics. I have to give me 1 second. I come back in. Okay, sorry for the inconvenience. Okay, and as I was saying, this SVG is a format that we can use to create these vector-based graphics and elements, and this is perfect because what we want is to create this canvas in which you can place these vector-based objects that we can play with them. Okay, one of the key things of SVG is that it allows to create all these vector-based elements, and it allows to make interactive and animation of these different dynamic and vector-based and graphical components. Okay, I hope that you understand why we're using SVG, because this is a format which allows creating canvas, and in this canvas we can place all these elements which are dynamic and allows for creating visualizations as the one that we're going to create. SVG is the standard format. There are two formats actually, canvas and SVG, but in this case we're going to create and we're going to use SVG. So what I will be doing actually is I will create an SVG element within the HTML of this observable notebook. Okay, and to do that, what we are doing is the following line. Okay, okay. So what I'm doing actually is I'm creating this SVG element, and then I'm asking. I don't know if you're familiar with HTML, but DOM is the hierarchy of elements in an HTML web page. Okay, so it starts by the document, and then it goes to I don't know, to paragraph, and this paragraph may contain a list. So this is a hierarchized structure of elements of HTML elements that makes the HTML web page. Okay, this is the DOM. So actually, what we are doing here is using this DOM function and creating an SVG object. Okay, which have this width and this height. Okay. So this will create an empty rectangle, okay, in which then we can use it to place all these vector-based graphic elements that will constitute our network, okay. So DOM, we're asking to the DOM to create this object with this SVG object, and then we're asking D3 to select this object and put it in this variable. So we can now put these elements. So by using this variable, we can now modify this SVG rectangle and place the different components of the network. Okay, just to be really clear, you see what I did here? I just created this DOM SVG, creating this SVG HTML element with this width, which, remember, the observable is providing the width, and this height. Okay, and then I am selecting I asked DOM to create it, and then I store it in this SVG. And then what I'm doing here is that I'm sending this SVG as an HTML element, so it can be rendered. Okay. Well, I hope you could grasp the notion. This is a bit advanced, but I would like you just to grasp the intuitive ideas of what we are doing. Okay. Now, so we have this SVG, and this is it's like a blackboard or a whiteboard in this case. And in this whiteboard, now we can place all these elements. We can place the nodes, the links, which are vector-based elements. Okay, and that's why we're creating this SVG. And what I'm doing here is I just this block is the output of this block is this SVG notebook, SVG object that I'm going to populate with all these different components of the network. Okay, so the first thing that I'm going to do is I'm going to create the links, and in order to create the links, I'm using this SVG whiteboard, and I'm appending a G. A G is nothing else than a group in SVG. It's like a folder of objects. A group is invisible, you don't see it, but it is used to group different graphic-based components that we want them to behave in the same way, or we want them to have the same attributes or properties. Okay, so I'm creating this group, which, as I said, is invisible, you won't see it, but it allows us to group all these elements. Okay, and then what I'm doing is I'm saying that all these I'm saying that this group should have this attribute. Okay, so I'm saying that this group that will contain the links, and the links are these dynamic objects which are lines. Okay, they are lines that are grouped in this G. I'm saying that this G, all the people that lives in this G are going to have the color of the stroke, the color of the links should be gray. The opacity of these links should be, maybe I'm going to simplify my life. The color of the opacity of the links should be almost like 60% opacity, and the thickness of the links that are placed within this group have to be had to have this width 1. Okay. Then what I'm saying is that, okay, now I'm creating this group, which you cannot see. In this group, we will hierarchically store these line elements, which actually will be the lines, that will be the links, because they are lines. Okay, do you see the relation? We're drawing lines, and we are creating these lines in SVG, which will be the links, and just nothing else than lines, isn't it? So what I'm doing is now, okay, I created this group element in SVG, and I'm saying, okay, in this group, select all the lines that you have inside. Now it's empty, but don't worry, because what we're going to do now is, okay, I'm going to use this data, and with this data, please, in this group, create all the lines that are placed in this data. Okay, so let's remember, we arrive here, we create this G. Okay, we are here, we create this G, and then in this G, we are saying, okay, in this G we'll store these lines, so select me all the lines that you have. If it's empty, there will be no selection, but it's not a problem, because there I'm sending all this data, and by using this data, please create me all the lines that represent univocally this data that specify the links. Okay, now it's actually not floating anything, but this is normal. Yeah. Okay, now we created the links. Little by little, I guess that it will become a bit more familiar with this way of proceeding. This, I mean, this is a really express class 2 D3, so it's a bit extreme, but this is the basis, really, the basis of D3. If you grasp this, then you're really good to go. Now, what I will be doing is creating a scale, which allows us making a mapping between the values of the degrees of the nodes and the radius range that we established at the beginning. Okay, so this function here, what it's doing is nothing else than finding the minimum and the maximum degree of the nodes. You see, 1 is the minimum degree, 60 is the maximum degree. For this, what I'm doing is using this map function in Lodage, which if you have time, explore it by yourself. Then I'm saying like, okay, use this object of nodes, then take all the degrees, and then take me the D3 extend is used to take the minimum and the maximum value of a list of values. Okay, so these are all the degrees of the function, are all the degrees of my nodes, and then I'm using D3 extend to create a new array that contains the minimum and the maximum degree. Okay, and then this 1 and 60, I'm placing it here. So this is a scale linear from, and remember the scale transformation from 1 to 60 to the radius range, which is the minimum size nodes of our nodes and the maximum nodes size. Okay, so we have this linear transformation between the values that we have in our data and the nodes size that will be in our network. Okay, bear with me. I know that this is complex, it's difficult, but bear with me little by little. If you want to explore more, this will make sense. Okay, now let's create the nodes. For doing that, the way of reasoning is exactly the same. I'm going to, sorry, I will share the video in case anyone is still alive. So what I'm going to do next is I'm going to do the same that I did until now. I will append some group. Remember, we have this whiteboard. We're creating this empty group, the group you don't see, but this group will contain all these nodes, which are cycles now. Before they were links, they were lines, so they were links. Now they will be cycles, so they are nodes. And what I'm saying is like, okay, create me this group, and I want that this group, all the elements that exist within this group, I want all of them to be well, the stroke, which is the outer line, I want it to be gray, and I want the thickness of the radius of the node, I want to be 1.5. Okay, and now it's the same. Select me all the nodes. If it's empty, there will be no selection, but if it's not empty, there won't, it will be non-null. Now load all this data, generate all the size. Okay, so again, we have this group. If there is no, there won't be no selection. So, and now I'm placing all this data containing the node. You see graph.nodes. And then what I'm saying is that with all this data in an univocal fashion, place me a cycle which represents all the values in this node. So there will be 60 nodes because we have 60 nodes. So there will be 60 cycles. Okay. And then at this point, I want the code to, for each of these cycles, to create an attribute which establishes the radius, and this radius is nothing else than this transformation here. Okay, so I'm using this scale that we used before, and we transform the degree to the variable that is codifying the radius. Okay, I just leave it here, and I want another attribute of these cycles because I want all of them to be orange. Okay. The final thing, sorry, is that okay? I created all these nodes. I placed them in a group. Then I say that each of these cycles, they should have some radius, which is based on a scale transformation from the degree to the property that I want them. And then I'm saying that all of these nodes should be orange. Okay. And finally, what I'm saying is that this line of code, what it's doing is adding the interactivity for the drag function. So you remember that we declared this drag function at the beginning. So by saying this, I'm sending the simulation of forces, and I'm sending this drag function. And this is what it's doing, is that when I'm moving the nodes, they will behave as the drag and drop behavior that I'm specifying in this function. But don't worry exactly about this. It's just you to understanding this. Okay. What is missing? Let's start again. We created this simulation. We created an SVG, which is an object, as we see, is a format. In this case, an HTML element that has this format that allows us to have these different vectorial components. And these component vectorials are a set of lines that actually are codifying this information of links. And they are gray, they have this opacity, they have this thickness. Then I'm creating these nodes, which have this thickness, which I'm adding a cycle. I'm adding all these cycles, which will represent all these nodes, and I'm saying that all these nodes should have this radius, have this color, and should behave in this way when I'm moving them. Drag is moving object. Click and move. That is drag. But what is missing? We need to specify how this simulation will behave. And in order to do this, I will be using this simulation .onTick. Okay. Let me share with you also this, if anyone is still following me. Following what I'm doing in real time. Finally, yeah, the final thing that we have to specify for this network is that, and let me explain to you what this does intuitively. The simulation, every time that there is a tick, and tick is minimum amount of time in which this simulation is run. So it is each of the steps of this simulation, which is automatically established. I think is less than 1 second, and actually some milliseconds. I don't know how many, but you can even change the tick if you want to make it more efficient, or you want to tune the simulation parameters. Okay. And for each of the ticks, what we are saying is that there is the simulation running. Okay, we have the simulation of all these forces. So what we are saying is that you see here, what this is doing is that for each of the links, we are saying that link position, this is the position of these edges, is established in the data, and this data is actually these values source xi. If you remember, this is not, if you remember, I mean, just follow the intuitive idea. This is not established by us in the JSON. This is something that actually the simulation is continuously creating, it's establishing, loading in our data, in our JSON object, which contains the data of this network. So the simulation is continuously changing these values, and what we are doing this is using the values that this simulation is loading in our data object to the physical position of the links. You see? Because this link goes from here to here to here to here, so it's a two dimensions, x1 I1 to x2 I2. So this simulation continuously is establishing this data in the simulation parameters in the data, and then what I'm doing here is just to place them. Okay, and I'm doing the same for the nodes. Don't worry too much. If you have time, explore this. This is meant also for the nodes to not disappear from the screen. I codified this by establishing some limit of the radius maximum. But the idea here is the same. What I'm doing here is just establishing where is the position of these nodes in the simulation, which is stored in this data file. Okay. I'm going to add also this line. This line, what it's doing is, this line is super important, because if we re-execute this cell continuously, and what will happen is that there will be n simulations. For n times that we're executing the cell, there will be n simulation runnings in a cascade mode. So if we don't stop, each time that we re-execute the cell, what will be happening is that there will be n simulations running in the browser, which actually will saturate the browser and will some kind of broke simply. That it won't be able to bear with all these simulations running simultaneously. So what we are doing with this line of code is saying, okay, when you re-execute the cell, stop the simulation, the previous simulation, and allow the next one to run. So we have just one single simulation running every time we execute the cell. Excellent. I forgot one bracket. Maybe no, but this is not the problem. I'm sorry. There is some open bracket, and I don't know what it is right now. I'm going to copy again this function. By the way, no, wait. Okay, no, I see. I guess that is the problem. Okay, sorry, now I see it. I just copied the function, I copied wrong. Okay, as you can see, now we have the network, and actually this network is, you see, it's alive. All the forces are being simulated, the forces that are attractive, the forces that are repulsive. Also the nodes, you see that they do not overlap because we included this force. This is working, and the system is alive. And when I'm dragging, the network is still making its simulation. And why, when I drag, the simulation is still working? Because I send to each of the nodes this drag function, which specifies the dragging behavior, and it should be compliant with the simulation that we defined at the beginning, which is this simulation here. Okay. And what I wanted to say, two things. The first one is that we have this simulation, this function of the simulation, we have it here. And the second one is that this part here, that is a bit complicated to understand, this join, select all lines, data graph, and join, it's the core of D3. This is a key pillar of D3. And actually this was kind of revolutionary when my boss invented this. At the beginning, it had a different name. And it is so important that actually I included here, exactly, these two resources are about joins. If you understand this, this is really like the key. I cannot devote more time to this because it's indeed complicated, but it's the way in which objects are dynamically managed in a way that when data is changing dynamically, new objects are being automatically updated. Okay? I won't be further than that. And now let me just show you something. I'm going to inspect this network. Let me see if this works exactly where you are. Exactly. Look, I just want to show you what we have been doing. I'm just created this SVG element here. You see. Now this is all our HTML web page. I created this SVG, and as I was saying you before, I created two groups. You see them? They are here. This group you cannot see, but you see that now is being shown in the screen. Because this is the group. It contains all, in this case, all the links. Yeah, exactly. This contains all the links. So if I open this group, boom, you see the lines? These are the lines. So this is one line, this is another line, this is another line, and each of these lines, now if I move this, you see? The parameters are being changed because the position of these links are changing. You see? And each of these links have three attributes in common. All they have this gray color, all of them has this opacity, and all of them has this thickness. You see? Because they are all placed in this group, and this group I'm establishing that it has these three attributes. Maybe now you start to understand better what we were doing before, in which we created this group and we said, okay, we want all the nodes to have this radius, which is kind of clear gray, and we have this thickness. And inside, okay, you have here all the nodes, you see? You see here, this one is John Coltrane, is the inner node. And I'm saying that it has to be, has this radius, it has to be filled orange, and it has to have this position based on the simulation that is running. So if I move them again, you see, all the values are changing. Okay, sadly, the time is running. So if you allow me, I'm going to just show you one final thing, which is, well, it depends if you're really motivated, we can do something else, but at least I would like to show you how to add labels, which is not really difficult, and actually it follows the same logic as what we have been doing until now. Let me find them, exactly. So the first thing that we should do is not this, but this, exactly. Maybe we can even do something else. The first thing is that to add labels in the node, in the notebook, and in the network. Yeah, tell me, Albert.
How much time do we need?
I mean, let's keep to 5 minutes, and
Because
if everyone wants.
there is another subject starting at 5 o'clock in the room.
Okay. So then, yeah, okay, then it's fine. So let me say, okay, I will just add the labels like this. Okay, so I'm doing the same thing that we did for nodes and for the nodes and the links. I just add, you see, the same thing, and I'm adding here the simulation. I'm including them in the simulation. So if I rerun, now you have them, okay? And now, for instance, something that I wanted to show you is that now we can modify this value, and we can instantly make it 50. So now I increase I'm changing the parameter of the overlapping, you see? So now the nodes, we can read them better. And since we are using the observable environment, what we can do, for instance, is we can create a slider, and that's why we have been talking about the sliders at the beginning, you see? And now I created this slider that dynamically, what it's doing is changing this parameter in real time, okay? And there is much to do, but this is more or less the basic idea, you see? But this is important because now, for instance, if we are running a static visualization, maybe we have some overlapping of nodes, maybe it's not clear, but we created this live simulation in which nodes are alive, in which also we allow for interactivity. We can move the nodes if we wanted to make it more clear, you see? And we can also modify the parameters of our simulation to make it more clear to the user, and we can make this real time. So it's dynamic, it's alive, it's interactive. So it's way easier for the user to understand all of what's going on, okay? And well, I'm a bit sorry because I think we don't have time to explore the Louvain, but the idea is then we can codify in real time the colors in the network. But what I will share now with you is this version of the network that actually it's available online, which contains the final version. It's a bit advanced, okay? There are further options, but it really shows all the possibilities. Well, all the possibilities, there are infinite possibilities, but there are this is the final version, you know? We have this is the same network, as you can see, but the colors here are the communities. So if you have a bit of time, I really invite you to check how this is being constructed, how Louvain is being detected, and there is also another functionality that I added here that is this one. I really love this, because you see, this really allows, that is the reason why we use interactive networks, you see? Because if you're interested in André Jolivet, by just hovering hovering the Jolivet node, you can see who are the collaborators, and we can even move like, oh, it's not clear to me, let me explore a bit different, you see? So we are really enhancing the possibility of exploring the complexity of the data that there is in this network. Okay, so I will just share with you this final version, and I hope that you can spend some time playing with it, and that you can spend some time just trying to understand again and again what we did. I try to stress with you how is the intuitive basis of how D3 works, and on top of this, the rest is just adding more and more functionalities. Then you can just, with a bit of time, explore it here. The whole code is completely documented, so I hope it helps you to understand a bit better what is going on. And in any case, it's one. I think one of the aims also of this class is to give you a bit of intuitive and opening your eyes to the possibilities of creating interactive notebooks, but also of using observable notebooks to plot and present your research results. And that's all. I don't know if you have any doubt. We are just at 5 o'clock, so maybe you have to go to another course, but any doubts, anything, I'm here. And let me know that before I stop, that you can just, at the end of this observable notebook, you will find, just at the end, you will find, sorry, because now this is open, my email address. So if you want to contact me, if you have any doubt, please do not hesitate, send me an email and I will answer you happily. And that's all. Thank you very much for your attention. I hope that it was useful and it was you learn as much as possible.
Okay, and now thank you very much. It was a very dense.
Completely, I know.
No, that's it. Thank you very much. Actually, so you have time, so you know that it has been recorded, so you can read the recording of the previous video. You will get also a recording of this section. So probably you will need and then go step by step. Of course, now it's also sharing all the code with you, and then you can use this as a kind of a source of inspiration for when applying this to your particular problem. And the idea is that, as I was saying at the beginning, not try to develop some code from scratch. Just take, for instance, you can take this one. Of course, don't look at the same data, exactly the same data set. Do something different, but take this as a starting point. Just become magic. So there is a lot of code, but of course, now has this code a lot of but its own hands. So for him, it's very easy starting from and trying to do that. But I think it can be very useful. So you have all this information, and then you can work on this for a week, and then we talk to. So and then I see the other people waiting. So now, thank you very much, and I hope to see you soon somewhere. Thank you.
Just the same. Just let me say that I totally agree with Albert. Do not start from scratch. Maybe play with this one and try to break it in small pieces and just substitute in this line your JSON file, and it should work automatically, okay? So, well, have fun if you engage with this, and thank you for your attention.
Bye.
Bye.